In this topic, we're going to start with learning how to refine the results of our entity extraction now that we're familiar with XPDL. First, we'll start by discussing some of the formatting functions we can use in our XPDL rules. Let's start with an example to understand why we may need to refine our entity extraction results. So when we write a rule to extract an entity, the extraction is returned as a string which looks exactly like the text that was matched by our query. So for example, if I use the function number as my query, it will capture 57 and 4. As you can see, one number is captured in its digit form, as it appears in the text, and the other is captured in the word form. If we wish to use this for further analysis, it'll be useful to have them both in the same format, whatever we choose that to be. So we can modify those with formatting functions that we write into our XPDL code. Now here's a summary of some of the more popular formatting functions in XPDL. And you can see that these functions perform a variety of formatting tasks, like changing the data type, changing the capitalization, and even modifying the resulting text. So let's look at a specific case where we need to change the data type. Suppose we're extracting patient data and we want to filter out the patients who are over a certain age. And let's say we've extracted the following information from the text. Now, if we want to use the entity function to return only the patients who are over the age of 55, we're going to have a problem. That's because the default output setting for our data is to be listed as a string. So the computer sees the age 62 here as text, and we can't use numerical operators on text to filter by age. But if we make sure that the data type of age in our output is a number instead, then we'll be able to implement this age filter in our query. Here are 3 XPDL functions for changing data types. toInt converts a string of numbers into an integer. todouble converts a string to a number, rounded to 2 decimal places. And toText converts a string to text. So, for example, if we have this list of extracted numbers and we use the toInt function, these values will be converted to what we see on the right. Notice how the numbers that include digits after the decimal point are rounded using this function. Also, notice that the data type here becomes integer. But if we use the todouble function, they're converted like this. They're rounded to the nearest 2 decimal places. And the last function that changes a data type is the toText function. By default, any extractions with XPDL are strings. So strings are categorical variables like yes and no, or green, yellow, and red. Text, on the other hand, is a more complex data type where we can parse the linguistic parts of it. So we can extract features, like these strings here, out of the text data. Now, in general, strings are usually better suited for further analysis. For example, if we're building models based on the information we extracted, or if we're presenting our results in categories. But sometimes we may wish to further analyze our XPDL extractions using a linguistic approach. And in these cases, we can use the function toText to make these convert from string to text. Now, let's move on to normalizing the form and the capitalization of our entity extraction rules. As we can see here, we've extracted card parts that are leaking. You can see that some of the results are in uppercase, and some are singular while others are plural, so the verb leak has been found in a variety of forms here. And if we try to find significant connections between car parts and problems with our results as they are, the computer will treat each of these as different issues in car parts because of the differences in case and form. This is why we need case and form normalization. And this is actually a very common task that we do after our entity extraction. So once we do that, you see that we now get an accurate representation of the significant connections in our data set. So here are 3 XPDL functions for changing capitalization. To lower converts a string to lowercase. To title converts a string to title case. And to upper converts a string to uppercase. For example, here we have results with different capitalizations. And once we use the function to lower, we get all our results in lowercase. But if we use to title, we see that the first character in the word is capitalized, while the other characters are lowercase. And finally, if we use to upper, we get our results in uppercase. Of course, this solves part of our problem, but even with this change, a machine would still recognize leak, leaks, and leaking as 3 different issues because they don't have the same grammatical form. So here's where we'll use the normalize or norm function. Both of these do the same thing and return our results in the same form. Essentially, this function takes a token or word and returns its lemma, or the main form you'll find for that word in the dictionary. And another relevant function I'd like to mention here for modifying text results is concat, which concatenates 2 or more strings. Let's start with form normalization first. So suppose we have these different forms of come apart that are captured. When we use the function normalize in the result block for the named group issue, all of our results now have the same form. Let's take a look at concatenation now. Here, we're capturing different word patterns for the same concept, that the AC is blowing warm air. So what we would like to do in this case is capture the AC as our component and concatenate it with the text blows warm. So we can generalize all these different forms of expressing this concept. So for this case, we're simply using the concat function to achieve this. And we get the phrase air conditioning, which is the name group comp, and blows warm, which is the text we added. Now, one of the questions that usually come up at this point is, can we combine formatting functions? And the answer is yes. So in this example, we have text that reads, customer states that the wipers streaking on the glass. So our query is capturing the word wipers, and we want to return it in lowercase and also in its singular form. So we use the to lower function first, and inside that we use the normalize function, where we use the M named group that includes the word wipers. And this is what is returned after using these 2 formatting functions. So now let's switch to our polyanalyst project to try out some of these formatting functions. In this hands-on practice, we'll go over how to refine your entity extraction results. So we're working again with our car repairs dataset, and we're trying to extract car parts and issues from the text, and to also find significant relationships between these. But first, Let's motivate our task by seeing what our XPDL results would look like without refining and normalizing the results. So let's open this link graph visualization. Now, this link graph shows the most significant issues in car parts that are linked. So right now we see a strong connection between wipers and streaking, and then we see some other issues in car parts here, like leaking oil and valve cover gaskets, and wipers and streak here. Now we also notice that streak and streaking appear as different entities in our graph, and wipers is also listed twice, both in uppercase and lowercase form. So our task is to try and normalize our XPDL results and make this graph a little better. So let's go into the XPDL rule in the entity extraction node. Now we see here the entities our rules extract. So we can compare things later. The same rule is listed twice here, but we're going to normalize our XPDL results in this rule over here. So let's switch to the properties view for the XPDL rule. Here we see the rule for extracting car parts and issues. So what we're going to do now is modify the results block of this rule and make sure our match and resulting attributes are normalized. But before we start adding our formatting functions, let's take a step back and think about the types of things we want to standardize. First, we want to normalize the result to the same form. So we want streak to be returned as the issue whenever a form of the word streak is mentioned. This means that streaking and streaks will be normalized to streak. Next, we want for this data set to group similar issues or parts together by using the function toSynonym. So this helps us take care of things like coolant leaking and coolant oil leaking, which are essentially just different ways of describing the same issue. Lastly, we want the case of our entities to be standardized. So let's choose to make the format of all of our result attributes to be in lowercase. Now, to accomplish all this, we can make the following modification to our XPDL. Okay, so let's walk through what we did here. We basically nested our formatting functions to standardize our results. So we first start by normalizing the entities to a single word form. Then we standardize to a specific synonymous form. And finally, we convert those to lowercase. Now, let's double check our syntax. Okay, now that the rule looks good, let's test out our rule to see that it outputs what we want. Great, it looks like we're getting what we want as far as standardization. Now let's re-execute this and take a look at the results. So here's what our results look like when we add our formatting functions. And let's compare that to how it would look like without normalization. So we're already seeing improvements. Now let's go back and re-execute our downstream nodes to see the link graph. So now when we view our graph, we see just two sets of issues: leaking valve cover gasket and streaking wiper. And this concludes our topic on refining entity extraction results. Up next, we'll talk about how we can do something similar with our results outside of our XPDL rules by using XPDL post-processors.